Welcome to our online virtual learning. I welcome new people to our channel, and if you are new, I will recommend that you subscribe to this channel, like this channel, and share with your friends, and hit the notification button, and please give us your comment as to how you see our videos. Thank you very much. Today we're talking about bearings, and by the end of the lesson I hope that you'll be able to understand what bearings are and the rules we use in bearings, and also we know how to measure and describe bearings between 2 points, and you'll be able to use sketch diagrams to calculate bearings between 2 points. Let's look at some of the features or what is bearing at all in math. Bearings are used to express the angle between 2 points or 2 objects, and there are rules that we need to follow when measuring or calculating bearings. First, we always measure bearings from the north line, which I will depict as N in my presentation. We always measure bearing from the north line. Some books they will say North Pole, the north line. You must also express your answer using 3 digits. So angle 45 degrees should be written as 0.45 degrees. If it is already 3 digits, that's fine. If it is 9 degrees, it should be written as 0.09 degrees. Make sure it's always written with 3 digits. And also, when drawing or measuring bearings, we always measure bearings in a clockwise direction. We measure bearings in a clockwise direction. Okay, so I'm going to give you examples and explain to you how we employ these features and rules in bearings. So let's look at the first example. You're supposed to measure the bearing. Look at the bearing of P from O. So we are supposed to measure and explain the bearing of P from O. The bearing of P from O. Whenever you hear the keyword from, it means O to P. P from O actually means O to P. So it's a little phrase you need to understand. Bearing of P from O actually means O to P. So you need to start at point O and not P. You start at point O and not P. So you always remember the keyword from. That's the starting point. So you go to point O, and that is our north line, and we need to start measuring from the north line until we hit the black line connecting point P. That's all we need to do. So it's all about angle measurement. As you can see, this angle is an obtuse angle, so you're allowed to use a semicircular protractor. So you must align the protractor really well, making sure the zero line falls directly or aligns directly with the north line. So that is my alignment perfectly on the north line. And you see there are 2 scales, so you've got to be very careful. We are measuring, the angles are getting bigger and bigger and bigger, so therefore it is the outside scale I'm going to use. Don't use the inside, because the inside scale is falling. When you are measuring, the angle is increasing, so it should be the outside scale. And looking at the outside scale, it falls on 130 degrees. So we say the bearing of P from O is 130 degrees. Simple as that. It's just about measuring angles. Let's look at another example. Measure the bearing of Q from O. So the keyword from O, it means R to Q. R to Q. So you go to point R. That's point R. That's the north line. Start measuring clockwise direction until you hit the black line that connects Q. That's all you're supposed to do. As you can see, this angle is reflex, so therefore you need a circular protractor. Align your zero line with the north line, then start measuring clockwise direction all the way. Remember, it's always clockwise direction. So clockwise direction all the way. The black line falls on 250. Therefore, we say the bearing of Q from R is 250 degrees. So these are the 2 examples showing you how to measure bearings. Now let's look at how to calculate bearings. When it comes to calculating bearings, you need to be very good at some angle facts. Corresponding angles. We say corresponding angles are equal and they make like an F shape, but the real angle is corresponding angles. They are equal. The next one is alternate angles. Alternate angles are also equal. They make like a Z shape, but the real name is alternate angles. The next one is co-interior or allied angles. Co-interior or allied angles add up to 180 and they form like a C-shaped angle. So we're going to employ these angle facts to help us calculate. Whenever you see calculation of bearing question not drawn to scale, you are not allowed to use a protractor. You're supposed to use your angle scales to calculate it. So, calculate the bearing of A from B. That means B to A. Remember, B to A. So we go to B, and we're supposed to measure from the north line all the way until we hit the black line. And we are not actually measuring, so we need to calculate. So we are calculating the angle bounded here. This is the angle you're supposed to work out. That's the angle you're supposed to work out. So how do we start? So many ways of doing that. That is 110 because corresponding angles are equal. So 110 here is equal to this 110, and that makes the angle look like an F shape. That's why it's called corresponding angle. F shape is corresponding angle. These two angles are equal because they are corresponding angle. And that is a straight line. That makes the angle at the bottom here 180. Therefore, if I'm looking for the whole angle from this point all the way to the black line, I need to add 180 and 110. That gives me 290. So therefore, the calculation of bearing of A from B will be 290 degrees. So bearing of A from B is just 290 degrees. Simple. Next question. The diagram below shows the bearing of X from Y. Calculate the bearing of Y from X. So from X to Y, that's what we are looking for. X to Y. So we go to X, that is X. We just need to measure this angle. Calculate this angle. That's what the requirement is. Calculate this angle. Okay, so we start again. We know it's 85 degrees because angles around a point is 360 degrees. So 360 minus 275, 85 degrees. These two angles are called co-interior angle, and they must add up to 180 because they form like a C shape. Co-interior angles. If you review your angle fact, you understand these terminologies. So allied angles or co-interior angles add up to 180. That's why this is 95. Now that we know this is 95, we state bearing of Y from X is 0.95 degrees. Remember, 3 digits. That's why I have to put 0. The angle is 95 degrees, but in terms of bearing, it tells us that's what 95 degrees, 0.95 degrees. So we've talked about how to measure simple bearing. We talked about how to do simple calculations. We are now going to talk about how do you do sketch before you do the calculation. So simple question, we sketch it before we calculate it. The bearing of A from B is 136. What is the bearing of B from A? Okay. A from B means B to A. So we start with point B and we create an obtuse angle of 136. It's a sketch, doesn't have to be perfect. So you know this is an obtuse angle. So this is your B, this is your obtuse angle, and that's where A is. So if you want to know A to B, create your north line on A, and you need to calculate this angle. That's what you're supposed to work out. This 136 is B to A. That's what this means. So you're now going to work out A to B, which is B from A. That's what you're supposed to work out. So the same principle, 136 because corresponding angle like we saw previously. Then the blue straight line is 180 degrees at the bottom. So the total angle will now be 316. So therefore, bearing of B from A is 316 degrees. Let's look at one more example. bearing of O from P is 235. What is the bearing of P from O? Okay, let's sketch the first one. We start with letter P and create obtuse a reflex angle of 235. So that is a reflex angle. So that shows where O is. Now we're looking for this angle. Okay, you can work out this angle because 360 degrees for angle around a point. So that's the working out. 360 minus 235 equals 135. Reason is angle around a point. These two, allied angle or co-interior angle, add up to 180. So 180 minus 125, 55 degrees. So the answer is, because 2 digits, you need to remember to state it as bearing of P from O is 0.55 degrees. Now, if you remember, all that we've been doing is simple bearing question. There is no scale representation. This is pure simple bearing question, measuring or calculating or sketching and calculating. In our next lesson, we'll be talking about a proper scale representation. So this is an introduction to bearings so that you understand the principles involving bearings. Let's look at an exam question. This bearing question involved 3 points. The bearing of Q from P is 120 degrees. Another point R is at the beginning of 240 degrees. It's at the bearing of 240 degrees from Q. Given that the angle PRQ is 40 degrees, work out the bearing of P from R. And B, given that PQ is 10 cm, calculate the area of triangle PRQ. Answer in 2dp. So many information. So all you need to do is break it down step by step. From what I've taught you, you should be able to sketch things one after the other. Just consider this. Bearing of point Q from P is 120. Just look at that. So from P, create obtuse angle 120 to show the direction of Q. That's it. 120 is obtuse, not drawn to scale. So that is the position of Q. Okay. Second, another point R is at the bearing of 240 from Q. So this is your Q. There is another 240 degrees that you need to draw. Now you should remember that 240 will not come all the way here, because if it is 120, that is 60. And if that's 60, the whole angle left here is 300. So your 240 should be a line below this line. So anywhere that is a reflex angle is enough, anywhere. So that's your reflex angle of 240. And that 240 leads you to R. So you are almost done. The sketching is very important. So we just sketch everything that we need to do. Now it tells us, given that angle PRQ, therefore we need to make a straight line, and that angle is what we call angle PRQ. It's 40 degrees. So let's put the 40 degrees there. Now that we know this, we are supposed to work out P from R. P from R, like we said before, that means R to P. Go to R. This is R. Get your North Pole. And that's what they want you to look at. Work out this small angle. There's so many ways you could use your angle skills to work out. So let's see. This is 60 degrees because allied angles add up to 180. Given that at 60, now angles around the point is 360. We can now know this is also 60 because when you add these two, it's 300. 300 from 360 is 60. Now we can even get our answer from here. These two is 120. 120 plus these two must make 180. So 120 and 140 is 160. And therefore to make 180, this is 20. If you think this is a big jump, let's do it step by step. Can you work out this angle? Yes. Angles in triangle. What would that be? 80. Good. Can you work out this angle? Yes, because angles around the point is 360, so you can use 120 and 180, 120 and 80, that will give you 60. Now look at this. Can you see allied angle here? Allied angles add up to 180. If that's 60, that should be 20. So therefore, the bearing of P from R, state with 3 digits, is 0, 20 degrees. Bearing of P from R is 0 to 0 degrees. We've answered part A. Part B is just a connection of bearing to trigonometry. So let's look at part 2. It says given the PQ is 10 cm, so this is 10 cm. Work out the area of the triangle. Okay, and we know that with sine rule, if we calculate one side, we can use any included angle to work out the area of the triangle. So I can choose to work out RP or RQ using sine rule. I want to work out RQ, so I call this X. So the formula says a side divided by sine of the opposite should be equal to another side divided by the opposite sine of the angle. So X over sine 80 equals 10 over sine 40. If you don't understand trigonometry, don't worry about it. You might need to go and revise that before you understand how I'm using this to solve bearing question. X is now 15.32. So knowing that X is 15.32, the included angle now becomes 60. So I'm using 10 and 15.32. Included angle is 60. And the formula is A times B times sine C divided by 2, or divided by 2. And sine C is sine 60. Included angle. So works out to be 66.34 cm squared. So the area of triangle PRQ is 66.34 cm squared. So for those of you who don't understand what I've just done, don't worry. I'll find time in trigonometry as a separate lesson. This is just a connection that I brought into this lesson to connect bearings. So this is the end of our first lesson, introducing you to what bearings are. Look forward to lesson 2, where I will talk about scale representation in bearings. Scale representation in bearings. So you need to practice this initial one before you understand the scale representation of bearings. Thank you for watching. Subscribe, share with your friends, and thanks once again for subscribing to this channel. Bye.